guys, it is your boy Pete talking about hydrogen bonding, such an important concept. I told Wallace that I've died and I'm going to be in Ethiopia for my funeral, and he's going to be shocked and it'll be exciting for me, and I'll be back at the studio right afterward. So enjoy my studio audience as always. So what is a hydrogen bond? Well, Wallace talked about dipole-dipole interactions in another video. So if you haven't seen that already, go check that out. But a hydrogen bond is a special case of a dipole-dipole interaction. A lot stronger one for that matter. So, a hydrogen bond has two components, a donor and an acceptor. In a donor, a hydrogen is bonded to a certain element, and in the acceptor, we have an element which can be bonded to a hydrogen, but it doesn't have to be. In the interaction between the donor and the acceptor, the actual interaction involves the hydrogen of the donor and the element in the acceptor. So this is exhibited by a water molecule. So now we're going to take a look at this diagram. The central water molecule is acting as a donor for the above water molecule. So again, what we've defined a donor as is a hydrogen bonded to an element. So we see hydrogen is bonded to oxygen. And above, we see an acceptor. And we've defined this as an element which can be bonded to a hydrogen. It doesn't have to be. Here it is. We have oxygen bonded to hydrogen. So our center molecule is playing the role of the donor, and the molecule above the central water molecule is playing the role of the acceptor. So usually in these sort of interactions, the element bonded to the hydrogen in the donor and the element in the acceptor are usually nitrogen, oxygen, and fluorine, fairly electronegative elements. So how strong are hydrogen bonds? Well, looking at this, we see we have van der Waals hydrogen bonding and covalent and ionic bonds. And these are listed in increasing order. So hydrogen bonding is a greater strength than van der Waals, but a weaker strength in covalent and ionic bonds. The strongest hydrogen bond is seen in the bifluoride ion, or HF2-. And HF2- exhibits what's called a symmetric hydrogen bond, where the proton is placed exactly the same distance apart from the two identical atoms. So, what do hydrogen bonds do to water? Well, it gives them pretty unusual properties. So it gives ice a hexagonal lattice structure. It makes water have a very high heat capacity. It gives ice a low density, making it float on liquid water. And it has a high boiling point. So that relates to the fact that in order to break these hydrogen bonds, we need an increase in temperature. So a general relationship we can establish here is that the higher the temperature, the less the strength of the hydrogen bond. So where do we see hydrogen bonds? Well, I told you guys these are very important, so there must be somewhere. Well, we have them in our DNA. The bases of DNA are connected through hydrogen bonds. We also see them in our proteins and secondary structures. The reason alpha helixes and beta pleated sheets get their shape are through hydrogen bonds. We also see them in synthetic polymers like nylon. So this slide pretty much summarizes how much important hydrogen bonds are. Right now, you guys are enjoying watching A3Academy podcasts, and without hydrogen bonding, none of this could be possible. So again, guys, the more you know, the better you are.